Good morning, afternoon, and evening to all of you from wherever you are joining us today. Before we start today's session, please feel free to scan the QR code and do the event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link and the QR code again with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. This session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on a code of conduct. We display this at all Microsoft Reactor events that we run and is just a reminder to be aware of others. The key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Dinesh, our speaker for today's session. Dinesh comes with 9+ years of experience around data and cloud, deeply involved in implementing B2B SaaS products for big data and business intelligence, currently working as product manager for analytics squad at KissFlow. But for now, I will hand over to Dinesh to begin the session. Over to you, Dinesh.
Yep. Thank you, Rashmita. Just give me a minute. I'll set myself. Let me share my screen.
Yes.
Is my PowerPoint deck is visible?
Yes, Dinesh.
Okay. Yeah. Thanks for the opportunity to Microsoft Reactor and thanks for the attendees to take your time to attend this session. So let me start with a very general thing. Actually, technology democratization has led us to make available most of the best features to be available in almost all products in the line. This is not just technology, whether even the consumer products are also. It is not just one Coca-Cola. You have Coca-Cola, Pepsi, Thumbs Up, and many things in the same line itself, right? Likewise, in across cloud providers as well. Let's take Microsoft Azure as example. Different products in data analytics look alike when we just look at the on its features on top, right? So in this session, what I'm planning is let me share my learnings and how I just analyzed different frameworks for our use case and how I have chosen right data tech to solve our business requirement. Okay. So I hope it would help other folks who are watching this to set up the best data architecture by choosing right tools. So this is me. I'm Dinesh Kumar. And as Rashmita told, I'm a product manager at KissFlow for the analytics part. And also beyond my confines of work, I actively get involved in tech communities and share my knowledge wherever possible. So this is going to be my agenda. So I will be covering about each topic in a very basic fashion. The aim of my talk is to share my knowledge about understanding the difference between the tech stacks, which look almost same in terms of features, right? And I expect that audience know a little bit of basics, like what is a database, why a database is used, where the database plays its role, a kind of such a kind of basic knowledge, right? Yeah. So At this point of time, right, this 2021 and 2 or 3 decades before and after, this is a very crazy and slightly confusing time in the data architecture space because more and more companies are shifting towards data lakes. Yet the traditional data warehouse and also the database also continues to provide value as it is for how it was there for decades. Now, to add that, we have this increasingly popular technology or the framework called as data lakehouse and even the delta lake concept also, right? All these concepts I'll discuss here uh, will be common for will be very common and will be very base that would also fit for the Azure cloud as well, right? So how do you feel upon looking at the slide, right? So I just got this strange thought of adding the slide while having my breakfast, right? So the batter is same, and even though there are varieties of dosa, still our mind will be okay to choose the plain dosa at times, right? It's not that a veg keema dosa or mushroom keema dosa, whatever it may be, it could be added with extra ingredients and it could be so tastier as well. But still, our mind sometimes feel like, okay, I just have a plain dosa today, right? So likewise, whatever the latest things or the latest frameworks arise in this data paradigm also, the same old technology will be useful for some use case that exists somewhere, right? So it is not that the latest is always the best. Each one has its own value and it will play its role, right? So let me just brief demystify what a database is in terms of the architecture that lies behind the database. Okay, we all know the database is used for storing data, but what lies behind, right? So let me tell few differences or few artifacts of database, data warehouse, and data lake. Upon comparing that artifact, you will definitely understand what is different between these three paradigms. All three are storing the data. Upon all three, we are submitting queries, and they are processing those queries, and they are giving back the result. So that there is no change in that. But what lies behind and where it is being used and where it is not being used, right? So the first point is collocation of compute and storage. Okay. So what I mean here is just have a simple example of your laptop itself, right? You have deployed Microsoft SQL Server database in your laptop. Let's consider that. Okay. So in this case, the storage and the computation both happens in your laptop only, right? For storage, it will be using your hard disk. For the computation, it will be using your laptop's RAM and CPU core, right? This is what a database will be using, right? For storage, it will be using the hard disk. For the compute, it will be using the RAM space and CPU core. So if 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 it is a database, then its architecture will be something like the storage and compute will be collocated together. Okay, if there is a scenario that there is let's consider that the current data size that is stored in a database is 10 GB. Okay, and currently you are getting 100 requests, data 100 requests per minute. Let's take an example. After 2 years, let's consider that from 10 GB, it has increased to 12 GB or something. But the number of requests getting submitted has increased to 1,000 requests per minute. Okay. In this case, the database size have not increased, but the number of requests has increased to 100 times, right? Even though only the number of requests have increased, there is no other option to scale the compute power alone. Of course, you can increase your laptop's memory from 12 GB to 16 GB or 56 GB or whatever it may be. I'm not talking about the small scale of data. Okay, I'm talking about a big production system where if you need to scale up the system, then you need to scale up to the whole set of new hardware, right? You'll not be able to add, for example, if you think that, okay, we would need 40 GB RAM space, then simply you will not be able to add 12 GB machines to that database, right? Because database architecture is a client server architecture. There will be one server that accepts all the queries. It will compute it and returns to the client. The client can be of any number. So that is the architecture base of a database. Okay, client server architecture. And the other major artifact is databases chronology is schema on write, which is nothing but before you store a data into a database, right? You should have a definite schema that has been taught to the database. In a very simple way, what will you do before storing a data into the database? You will be creating a table, right? So you'll be creating a table, create table name, column name, and a data type. Like that, you'll be creating that schema, creating a table with a definite schema, right? And then only you will execute the insert command, right? Insert so row primary key and row number 1, row number 2, sorry, column number 1, column number 2, like that you will be inserting the data. So before you write the data to the database, the schema should be there. That's what I mean here as schema on write. This could be a very known factor, but you'll understand the analogy when I talk about data lake and all those things. Okay, so to be open, when I'll be personally recommending a databases, if your data is of a structured type, okay, right, that is purely it is of rows and columns of kind of structure, and it is the data size is obviously of less than a terabyte. From now till 5 years, if your data size is not going to grow beyond a terabyte, then definitely you can choose a database. And you can also question me that structured data means that there are NoSQL databases also there, right? Mongodb and all those things. Of course, if you have at least to a limited level of flexible schema, okay, not too flexible, but just a limited level of flexibility. For example, let me take three levels of schema, okay, parent, child, and child. Like that, if you have 3 levels of schema, then yeah, someone talking. Okay, fine. So if you have 3 levels of schema, then obviously you can choose a database. But this will be a very large topic. So I just brief it with these 2 points alone. If it is of structured data and if it is of semi-structured data with a very limited level of sub-level. Okay, if it is of 3 or 2 levels, then you can choose a database and have the purpose of database to solve only one thing. Either it is OLTP or OLAP, right? OLTP is nothing but purely the database will be serving for the applications usage, online transaction processing. Okay. OLAP is nothing but online analytical processing. That is for the what to say, analytics kind of workloads. So in OLTP, most of the queries that are getting submitted will be create and insert, right? When it comes to OLAP, most of the queries will be of select queries based. Fine. So just have that have the picture in mind and use the database only for one purpose. Okay. And I'll not recommend a database if the purpose is purely for ad hoc analytics. Okay. You can question me that even a database can be used for analytics. Yes, it is true, but that kind of scenario, the database will be served only for the analytics purpose, not for the applications metadata purpose. That is OLTP purpose, right? Here, what I mean about ad hoc analytics is that the table will be there, and you might have a business question, right? In that case, you'll be directly hitting those tables joining 10 or 20 tables, having multiple group bys, having multiple aggregations, and all those things, right? If you do such a kind of complex queries on a database which is already serving an Oltp purpose, then definitely the database will outrun the memory space. Okay, so for such scenarios, don't choose for a database, right? If it is the service is for purely for analytics, then choose for a data warehouse. That I'll cover up next. And one more thing, if you have the dependency on sharding, right? More number of dependency on sharding. Sharding here is nothing but when you have a database attached to a to an application for more than 5 years or something, you definitely need a sharding, because no customer or very less people only would be querying uh, 5 years before data or 3 years before data, right? Mostly the current year's data will be only will be queried. So at that time, what the architecture pattern will be like? They'll shard the database, they'll shard the old data into some other different server, and they'll have the latest data alone in very hot server, right? For the query performance to be far better. So if you have such a kind of architecture need very soon, like in an year or so, then don't go for a database. Okay. So let me talk about data warehouse. So in the previous slide, I was mentioning that database concept is based on collocation of compute and storage. Okay. So what a data warehouse is meant meant in the architecture point of view is the compute and storage will be separated, right? So with the same example, even though your data sizes has not increased, but the number of requests alone increased 100 times, then definitely you can increase the compute space alone, and you need not worry about the storage at all, right? It can be hardware that is being used for storage can be as it is, and you can simply scale the compute power alone, right? And the other analogy is the same. Even if it is a data warehouse, you need a fixed schema before you store the data. Okay, so this is not pretty much different. When I'd be recommending a data warehouse is if you definitely know the metadata schema, right, or the format of analytics to be done, then definitely you can go with the data warehouse. And if the need for ML and or AI is not so much in the sense you would be having some needs, but not purely a machine learning kind of project, then definitely you need not choose data warehouse. And another thing is, if your use case is something like you need to expose your data to the customers externally, right? Not from within your application. You need to expose your data to customers, allowing them to analyze on their own. Then definitely a data warehouse is a very right choice, because it is the architecture is designed in such a pattern only, not even not in database, but in data warehouse for exposing out to customers in a very secure manner. The architecture will be so good. I'll explain this factor with a simple example while I show you demo in some time, right? And of course, when I'll not recommend a data warehouse is if obviously if your data is of image and video that is purely unstructured, then definitely don't go for a data warehouse. Okay. Right. So and one more very important factor is when you choose a data warehouse and even database, your actual data will be converted to proprietary software's format. For example, let's consider PostgreSQL. Then you might be inserting your data from a CSV or manually or whatever it may be. That particular data piece will be converted to a different format that can be understood by PostgreSQL only. Similarly, when it comes to data warehouse, if you insert data into a data warehouse, let's consider it is Azure Synapse or Snowflake data warehouse or Amazon Redshift, whatever it may be, your input data will be converted to the proprietary software's format. That is Snowflake's own format, Synapse Analytics' own format. Only then the data will be stored into the data warehouse. Okay. So While what happens in this case is, while leaving data warehouse, you need to have that data to be exported in a open source format like PAT-Q8 or ORC. Only then you will be able to come out of a data warehouse, right? You need the vendor dependency. That's what I mean, right? So let me jump on to the next thing, data lake. So as you could see, the separation of compute and storage is the architecture pattern of data warehouse. When it comes to data lake, separation of compute and data is purely done, right? So the data will be sitting separately and the compute will be sitting separately. Both will not have any dependency at all, right? That is a major different thing. And there won't be any conversion at all. The data will not be converted to any proprietary format. Whatever the format you are saving, that the data will remain in the same format itself. If you save it as CSV, then it will be in CSV only. If you save it as Parquet, then it will be in Parquet only when it is stored in a data lake, right? So you can have a single source of truth architecture. Data will be relied in single place, and all external systems can access over that same data, and it allows to set up to have a data democratization as well, right? So this is one thing, and the main difference between database, data warehouse, and data lake is it is about schema on read, right? So if it is data warehouse and database, it is of schema on write. Before you store the data, you need to have a fixed schema in the database and data warehouse, and on top of that only you can insert data. But when it is data lake, first job you will be doing is you will just dump the data into a data lake, right? You'll not worry about the schema at all. When the schema, when worrying about the schema or considering about the schema comes is while accessing the data, right? As you could see, this is the data, single source of truth. All the source systems will be dumping the data into data lake. And there are two different teams. Let's consider that there is a team of data scientists who does mostly of machine learning and predictive analytics kind of works. And there are BI users who use BI tools for descriptive analytics mostly, right? So there are two kind of users. So both of them can create separate compute service. One is based on Spark and one is based on some SQL service engine. Let's consider it as some Presto or some other thing, Apache Hive or whatever it may be, right? So if it is on Spark, at this point only, the data scientists will define the schema, okay? For example, let's consider that the raw data is having 100 columns in that data. Okay, the actual data is having 100 columns. The data scientists might need 50 columns alone. Okay, in that case, in this Spark service, in this compute layer, the data scientists will define their schema, right? While reading it, they'll define the schema with that 50 columns alone. Okay, they'll not consider the remaining 50 columns at all. Okay, similarly, when BI users for doing descriptive analytics, they'll they'll take whatever columns they would need at this SQL engine, and they'll define the schema as needed by them. So the schema, the original schema need not be worried at all by the data scientist or the BI users, right? They can simply deploy whatever the columns they need. They can simply create whatever the schema they need while reading that data. That's what I mean here, right? So another major advantage is there won't be any conversion or copying to another system. Data lies in single source of truth. See here, the first thing happens is usually from the source system, it will be moved on to some data lake or some cloud object storage places. From that, uh, via some ELT, the data will be converted and getting stored into data warehouse. Even from the source systems, the data might be stored into data warehouse, but obviously there occurs the data copying, right? For example, let's consider that there is a sync interval between 1 hour. So always 1 hour of delayed data will be present between the source system and the data warehouse. But in this case, it's not so. Whatever source systems data has, it will be directly stored into data. So always it will be a single source of data, right? So when I would recommend a data lake is if you have all types of data of any size, right? You might be having image, you might be having what to say, text or whatever it may be. Let's consider a very simple tool which is known to all, Canva. Right? Canva is being used by multiple people to create banners and all those things, right? So Canva would be having its metadata, would be having the text which as a user I give in the each slide, and would be having the images which I upload to the Canva. So multiple data will be there, right? So in that case, I can have a single data lake bucketed and architected very clearly to store images and text and metadata as well. And on top of that, the application can have its design accordingly, right? So this is one simple example. And some other case, you might be having a scenario like just store the data now, but don't do analysis as of now. Let's just store the data, and after some span of time, let's do some analysis, right? So in that case, you can definitely choose a data lake, right? Because storage is pretty much cheaper in a data lake, but not in a data warehouse. Even if you choose a data warehouse just for storage, the cost comparison will be more in data warehouse than data lake. Okay, so if the purpose is just for storage for now, then definitely you can choose a data lake. Mostly for internal analytics, such a kind of scenarios would occur. In all the companies, the website logs data and the customer support tickets data and all those many data will be there, right? And how the telemetry data, how their product is being used. So all such data will be there, and all those data will be dumped into data lake, and specific teams would be taking out the respective data, those data they need, and they'll analyze only at some point of time. They'll not analyze all the time, right? So in such internal analytics use cases, a data lake would be a very right choice. Okay. And when I would not recommend a data lake is if you have a scenario like uh, the data that you store should be immediately available for analytics, then data lake might not be a right choice. Okay. And if you need some systems where you might not know the number of requests or the number of requests submitted per minute kind of thing, then data lake might not be a right choice, because the compute is need to be designed separately, and you need to have a look on this compute manually all the time, so that there is no uh, outage of requests, and all the requests are handled seamlessly, right? So in that case, the better choice would be a data warehouse, right? So I'll just take a pause. If you have any questions, please unmute yourself and ask. Okay, so I think there's no questions. I'll continue.
Only one part. Even you told that data lake, there is a separation of compute and data, I mean storage. That is true even for the data warehouse also. If I'm talking about Azure Synapse Analytics, on-demand SQL, that is SQL data warehouse, nothing but. That also separate the compute and data, I mean storage.
Okay, there comes a what to say, the base architecture that is dedicatedly designed is data lake. Even it is possible, I mean, even it is been happening in data warehouse also, but not in a 100% manner. That's what the scenario would be. And also, when we talk about Azure Synapse, they are moving towards an architecture called data lakehouse, right? So they are having their architecture, both the data scientists and the BA users are getting benefited. That's why you will be able to create Jupyter notebooks also, and also you'll be able to connect with Power BI to play with the data, right?
Yeah, in Power BI, I can connect with data lake also directly.
Yeah, you can connect, but how can I say, the everything is possible, right? Even with database also, you can have this analogy. But the architecture behind each of this system, how it is being present in the architecture level. That's what I mean here.
See, data lake as per our architecture, it is basically serve as a raw storage layer where the data ingestion is faster. You can dump the data very quickly in hierarchical fashion, at least in ADLS Gen 2. But if you are talking about the separation is one of the advantage, like Snowflake, they are 100% separated. However, in data lake, it's object-based storage, so we can store as an object and we can have the life cycle policy. That I agree.
Yeah. Okay. So can I proceed?
Yeah, sure.
Thank you. Okay. So obviously, why these different types exist, and almost all of these can solve each other problem, right? Obviously, that would be the basic question, but each type would be solving different problem statements, right? And there is a very common statement that when NoSQL came, people spoke that RDBMS will die soon. Similarly, when big data was at its peak, like big data was future and big data is all about, and they were telling that okay, the DBMS might die soon, right? But it is not so. So it is the same analogy when it comes to the application development. When microservice architecture was booming, people were talking that okay, no, in monolithic based application development will not be not much, right? So what I'm coming to say is whatever the new technology comes in, the existing scenarios, the existing categories also will exist, and it will have its own ISP, and it will solve specific problem statement, right? So that's a general thing we also learned at while we are switching between these three and deciding upon one particular thing. So let me jump into the actual thing. Azure Synapse Analytics and Azure Databricks, right? So let me tell what core things are being addressed by Azure Synapse Analytics and what core things is being addressed by Azure Databricks, and what are the common features that is present between these two. What is the very minor difference that exists for those common features? Okay, so as many of you know, Azure Synapse Analytics is nothing but Azure SQL Warehouse rebranded. They not only rebranded it, but also they have a clear separation of compute and storage, and they have deployed on-demand SQL pools and provisioned SQL pools as well. Here, on-demand and provision is nothing but if you pretty much sure that this would be the data, the incoming request size and the data compute is going to be happening, then you can provision, create a provisioned SQL pool, which will be pretty much little bit of cheaper. But when you typically never know what would be the size of the number of requests and all those things, you can simply create on-demand SQL pool, right? So this is where there are a lot of architectural differences. I mean, new features that has been introduced in, and of course, many open source technologies like Spark and Data Lake were introduced into Synapse Analytics. And when it comes to Databricks, primarily to play on top of Data Lake, you'll be able to play on top of Data Lake, and it is a hosted Spark environment. That is, Databricks will be providing Spark as a service, right? And also it has been extended with the Delta Lake, MLflow, and SQL Analytics as well. SQL Analytics means you can play on top of data with SQL queries as well, Spark SQL, I mean here, right? So it is a very best option for machine learning workloads, especially if you have your tech stack, especially data stack within the Microsoft Azure, right? If you have your data stack in Azure Data Lake or Azure Blob, then definitely Azure Databricks is a very right choice. And let me quickly give a brief overview, very simple explanation about Delta Lake. So it's nothing but you'll be having the data in the data lake, but to have the advantage of data warehouse, that is atomicity, uh, atomicity, consistency, isolation, and durability, then you can store that same data into a different format called as Delta Lake. Within the on top of the Delta Lake format, you'll be able to play the data from the data lake itself with atomicity. You will be able to create it, insert it, update it, and delete it as well with ACID compliance, right? So this is a very simple code snippet I just copied from a website. So just to make you understand that the data is same and it is being converted to a delta format. That's it. The data is same and it is converted to delta format. And on top of the delta format data, you will be querying the data, right? So that's a very simple explanation. I'll come why I told this in very soon. So I don't have a provisioned Azure Synapse Analytics. So I just added screenshots alone for those who are very new to Azure Synapse Analytics. So this is the this will be the UI of Azure Synapse, where you would be having separate tabs, right? For data, develop, orchestrate, monitor, and manage. So the data tab will be of simply for the storage purpose. Those who are responsible for storing the data, ingesting the data, they'll be mostly using this data and the orchestration pipeline. For people who are on the BI user side, right? Those who are analyzing the data, they won't be considering these two things. Mostly they'll be into develop development tab, right? So like this, they have clearly separated, provided a beautiful UI and articulated all those tools into one single tool, that is Azure Synapse, so that people can, the whole data team can work together in a single tool. So as you could see for ingestion, this is nothing but the Azure Data Factory. And for exploring, you could see the databases listed in the in this, and the storage accounts. That is, you might be having different storage accounts, and within each storage accounts, you might be having a different set of files. All this you will be able to see here. One more beauty is the overall admin can assign which storage account or which particular data should be visible for respective person, right? The data governance is being handled so beautifully that's why the whole data team can use Azure Synapse Analytics as a single product at their end. And of course, if you are a data scientist or a data analyst, you'll be able to play with SQL queries directly, or even with Python or with R language. So, and of course, with Power BI embedded into, for the visualization purpose, into Synapse Analytics itself, you will be able to visualize the dashboards, and you will be also able to do the basic editing, right? Basic editing within the Azure Synapse itself. So that's where Azure Synapse is being traveling into. They are clubbing both the big data world and the data warehouse world together, and they consider calling themselves as big data analytics, right? So, sorry, Synapse Analytics. So that both the entire data team can work together, right? And let's jump into the next portion of this talk. What are the common features that are available both in Synapse and Databricks? So if you see, all these features are available both in Azure Synapse and Azure Databricks. Let me explain one by one. Both of them provide Spark and Delta Lake as a service. You need not worry about installing Spark. You need not worry about the hardware part. You need not worry about the uptime and all those things. Both Synapse and Databricks will be taking care of that. But what is the difference? Azure Synapse is using the open source version of Spark, whereas Azure Databricks is using the latest version of whichever is being released by Databricks itself, because this is the actual core company which has created the Spark, right? So that's the major difference. And when it comes to Jupyter notebooks, which data scientists will be using for writing the Python scripts and playing over the data, Azure Synapse Analytics is using Interact type of notebooks, whereas Azure Databricks is using Databricks is its own notebooks. And the major difference is it will be real-time co-authoring. That is, if you take Microsoft Word, multiple persons can edit the document at the same time, right? And all other persons will be able to see what others are editing. Likewise, real-time co-authoring feature is present in this Azure Databricks kind of notebooks, but not in Interact notebooks. And there is automated versioning also. If you want to switch back to yesterday previous versions of notebooks, then it will be easier to do when it is Azure Databricks. And when it comes to access data from a data lake, both of them can access data from a data lake. The simple thing is Azure Synapse has a quite little bit of advantage to easily query on top of it via SQL scripts, right? When it comes to Azure Databricks, you need to write a portion of code to mount the data lake, and then only you will be able to start querying on top of it. And obviously, both have Python and SQL environment hosted. So in a very general term, for ad hoc analytics, Azure Synapse is very good. For ML flow, Azure Databricks is very good, right? So when it is of compute separate architecture, as one of the speakers has told, Azure Synapse Analytics has the architecture base as SQL on-demand pool, and Azure Databricks has its architecture base as Autoscaling pool. I'll show you how Autoscaling would be there in the demo in few minutes, right? So when can you use Synapse or Databricks at what scenario, right? So if you have a scenario where you have ad hoc data lake discovery that is needed, then both Synapse and Databricks are obviously you can use. If your scenario is mostly for SQL analysis and data warehousing, then obviously Synapse is the better choice. If it is of self-service BI and it should be for reporting purpose, where your users are mostly from the data analysis side, then Synapse is the right choice. And same data scientists should play via Spark, and data analysts should be play via SQL, and BI people should play via using Power BI. Then definitely Synapse is a very best choice because you can have a single within the data lake itself. You can have it as a single source of truth. Uh, and all three teams can play with it. That is data scientist, data analyst, and the business intelligence team as well. So all three teams can play with it. But when it comes to Databricks, if your scenarios of more of machine learning and the tasks nature is of GPU intensive tasks, right? Then the preference is Databricks. Still, the GPU intensive tasks are possible in Synapse, but in my personal opinion, I suggest to go with Azure Databricks. And if your dependent tech is much on Delta Lake format and Apache Spark, then Databricks would be the right choice because they'll be having the updated stable version before they publish it for the open source, right? So Databricks would be the right choice. And if you want a Git-based developer experience, that is, you want to commit or if your compliance is of Git-based, then Databricks is the right choice because Git-based developer experience is not yet available in Synapse. I think it is in the roadmap, but I'm not sure whether it is available now. But so far, it is not available. So with that, let me quickly show what a Databricks is, how a Databricks would be present for those who have not came across how a Databricks would be, right? So I'm right now in my Azure portal, and let me just quickly create an Azure Databricks environment for a quick scenario, right? Okay. Let me just choose any existing work group, and let me just give a name for the workspace and choose my region, and I'm just choosing the tier, whether I need a standard, premium, or trial. So when it comes to standard, you'll be having the Apache Spark deployed as a service, and also it will be secured with Azure AD, right? This portion is still configurable when you deploy a Spark cluster on your own or outside of Azure, but you need to configure it on. But when you do it within Azure Databricks, and you already have Azure AD deployed in your organization. That is, as a Dinesh Kumar and being a product manager of one company, I have a basic set of what to say, accessing limit to the data lake, right? With such a kind of data governance is already there, then if you deploy the Azure Databricks, those governance will also be configured along with the Spark environment, right? And also when it comes to premium, you'll also have the role-based access controls as well. Within the Databricks, you'll be able to assign a specific table to specific user for visible, or you can assign a specific data set. You can assign a specific notebook for a specific user to play with, like all those role-based analytics, right? So this is the basic input, and if you just if you have any additional advanced thing, you can always go and check with this. These are all based on the complaints of the company. If the complaints of the company doesn't want the database environment to be hosted on a public IP, then if you just give yes, it will be hosted in non-public IP. And similarly, if your company have their own virtual network environment in Azure, then if you just give yes, and it will be asking you for the virtual network environment, specific virtual network environment, and the database cluster will be deployed into that specific environment. So whatever you do, it is going to be additional pricing. That's it. So for the timely purpose, let me get out of this and quickly show you a deployed Azure cluster, Azure Databricks environment, which I have already. So once the Azure Databricks is created, you'll be having such a kind of UI, and it's all about just launch workspace. If you just view that, you'll be asked to sign in as already signed into Azure portal, and it has been designed to be signed in with Azure AD. The sign-in happens automatically, and I'll be landed up to this workspace. So in this Azure Databricks, you will be having two different UI. One is data science and engineering, and the other one is machine learning. So when it comes to machine learning, mostly they'll be using this Databricks for AutoML purpose, and for creating a notebook to train some models and all those things. When it comes to engineering, they might import data, or they might even create an ML flow experiment, whatever they may do. So this is just a simple UI segregation that Azure Databricks has provided, right? So let me just jump into, okay, now let me show another thing as well. As you could see, there is two separate things. One is data and compute. So when I click data, you could see that I don't have any access to any databases. If not, I'll be shown with respective databases what are all the data sets I'm able to play on top of it. And also I'll be able to create table just within the Azure Databricks alone. I mean, just within the Spark cluster alone, right? So I'll be able to have such things or data. When it comes to compute, it's about the compute environment. What kind of compute environment I would need. So let me quickly create a cluster as an example. So as you could see, I can just give a cluster name on my own, and it will be asking me the cluster mode, whether it should be single node, standard, or high concurrency. Single node is nothing but one virtual machine, and it will be a standalone kind of thing. Like if you are installing Apache Spark in your laptop, it is nothing but a single node Spark cluster, right? So for that particular case, mostly for the development purpose and for the POC purpose, single node would be a right choice. And standard is the most of the time the type of cluster would be deployed, and high concurrency is nothing but if you want the request to be processed very quick and you need a very quick response time, then you can go with the high concurrency type of cluster. And in this case, you'll be having the independence to choose what kind of runtime you need. So what kind of Spark you need, and what kind of what version of Scala you need, and whether it is a GPU intensive or not a GPU intensive. So like this, I'll be able to choose the Spark Databricks runtime, or even I can leave it as this. And When it comes to autopilot options, I just told about how the difference in the compute scaling, right? If you have this enable auto scaling enabled, checkbox enabled, you will be having these two options: minimum workers and maximum workers. And if I uncheck this, it will be only one thing, right? What does it mean is, if I uncheck this, and whatever the number I give, it will always have that number of workers dedicated for the job getting submitted. Simply say the master slave, based on the master slave architecture, the driver is nothing but the master and workers are nothing but the slave, right? Always 8 slaves will be available to accept the job request and submit back. But when you just enable this auto scaling, you can assign that 2 workers should be minimum available minimum, and it can scale up to 8 requests. For example, when this database cluster is having 2 workers, and let's consider that 100 requests are getting submitted, suddenly 1000 requests are getting submitted. Okay, 5 times of that. So in that case, Azure Databricks by itself will scale automatically to 8 workers and accept that 1000 requests, and it will operate seamlessly. Okay. So yeah, is there any question? Okay, so let me continue. So this is what the minimum workers and maximum workers is all about. And of course, each cloud tech has solved this problem differently. When it is of Snowflake, even this particular work also would not be there. It will be very easy, and even a developer can understand very simply when it comes to Snowflake. But when it comes to Databricks, it needs a little bit of more level of so about when it is about auto scaling and all those things. And of course, the difference is there will be a slight delay to spin up the additional 6 servers in terms of Databricks. Okay, it can accept huge amount of requests, but there will be a slight delay to accept that, because to turn on that mission and to turn on that worker instance, and to add those worker instance into the Spark cluster, all those things. For that, a slight delay would be there comparing to Snowflake. When it comes to Snowflake, it will be very seamless. The scaling would be happening in seconds, and you even not recognize when the scaling has done and how it has accepted a huge number of requests at all, right? So that differentiation is there. And when it this option is nothing but terminate offer 120 minutes of inactivity. It is very simple, plain English, which everybody can understand. When there's no requests for at least 120 minutes, then you can automatically switch off this cluster. It is not that the cluster will delete by itself, just a switch off will happen, right? So again, someone should come in and start this cluster, or they might have some scripts to switch off the cluster when new job is getting submitted. And this is also being handled differently between different tools. Again, in Snowflake, if you take this the same feature, it will be very user friendly. When it is Databricks, it will be somewhat somewhat a manual work is needed. And when it comes to Azure Synapse, as I told earlier, on-demand pool, it can spin up the new instances on its own in a better time manner, right? In a quicker fashion, I can say like that. So this is all about the cluster, and I think I'll switch back to my presentation once again. Now let me explain my use case at KissFlow, and how we just solved our use case, right? So KissFlow is a pure SaaS product, because just to set up the context, let me talk a few words about KissFlow. KissFlow is a SaaS-based product, completely cloud managed, and it is a no-code product where customers, the business users, will be developing the workflow apps by themselves, right? The workflow apps is nothing but leave request application, travel reimbursement application, employee onboarding. All these are workflow apps. where the business users will be creating by themselves. Okay, so in this case, as you could see, the, the product will not have any control over the schema, right? Because one application might have 10 fields, another application might have 20 fields, another application might have just 3 fields, right? So as a product, we don't have any control over the schema. Okay, so each customer will be having their own schema, and for the OLTP purpose, we are currently using MongoDB that is hosted in Atlas, Cloud Atlas, and the data isolation is nothing but we have isolated one database per customer, right? Earlier we were using MySQL, but when the schema-less approach was going beyond a limit, we couldn't cope up with MySQL, and there were some other reasons also, like MongoDB was having better sharding option, and multi-instance option was also there. Development staging and production option was better in MongoDB than MySQL. So those were the option we is migrated from MySQL into MongoDB for the OLTP purpose. Okay, so we didn't have MySQL as our MongoDB for purely for the analytics purpose. Of course, we have a basic version of reporting within the product, but not as a what to say uh, advanced analytics portion of analytics as of now, right? So for that particular purpose, for advanced analytics, we were investigating to host a database itself, like Microsoft SQL Server or PostgreSQL, to serve just for the analytics, just for the OLTP, or can we go with data lake? Can we just dump all the data into a JSON format, because MongoDB is NoSQL and it is of completely of JSON. And why can't we dump the data as a JSON format into data lakes? And we even did a POC uh, by storing the JSON data into Google Cloud storage. And on top of that, we deployed Presto cluster. Apache Presto is a query engine that can run on top of a data lake. We did a POC on top of that, but the performance and other artifacts we were not able to get so seamlessly, right? The main thing which we needed is we need to share the data, because our customers, each of the customer, as I told earlier, one database will be there for one customer, and they are asking us to expose the data out, and they are ready to connect the data with their own BI tools, and they would be playing it on their own. Okay, so as an application security point of view, exposing a data is not a simple option, right? You should not allow, I mean, it is not an easy option. It is not that you should not, it is not an easy option. For such scenarios, data warehouse was a very right choice for us. And we finally chosen to go with data warehouse. And even we just productionized the analytics platform was KissFlow as well. So that's for my use case of KissFlow was there, and that's how I choose data warehouse as the analytics platform of KissFlow. So after database, data warehouse, and data lake, what's next, right? So in the industry, this terminology is being involved, and what is data lakehouse, whether it's going to be the next big thing that's going to be into the architecture field and all those things, right? So I have just curated it in my point of view, right? If you just Google data lakehouse, each one would be have told in a very different manner, but it is all about stringing together the best features of both different worlds, the data warehouse world and data lake world. That is where Azure Synapse is being projected towards, right? They already project that it is the best thing for both big data and the data warehousing. But in my point of view, still they are achieving towards it, right? Not 100% accurately best fit data lakehouse. I might not say it like that, right? So simply say the data structures behind the data warehouse and the management features of data lakes you could expect in a data lake house, right? And it will be a single point of truth for multiple solutions, and it will be very easier for data governance. This simplified data governance is already there in Azure Synapse, but I just mentioned in a common artifact, right? And obviously it will be cost effective too. And I just picked this slide from Databricks website, where they have projected the difference between data warehouse, data lake, and Lakehouse. So as you could see, the data will be there, and after doing some ETL, the data will be again moved into some data marts, or you could see consider this as cubes and all those things. And on top of the cubes, the BI layer will be working. People will be creating dashboards and all those things. And when it comes to data lake, the data will be present in the data lake, where it will be stored in all different formats. Again, based on different teams, uh, the what to say, there will be another copy of data will be happening. So data lake will be there. Again, there will be some preparation, data cleansing, where that will be used by machine learning team and the data science team. They'll be doing that. And similarly, by the BA team and the analytics, descriptive analytics team, they'll be doing some ETL. And again, they'll be doing storing the data into a data mart, say data cube, or some real-time database. And from on top of that, the querying will be happening. And when it comes to data lake, what they project as the architecture point of view is all your structured, unstructured, and semi-structured data will be present in this space. And simply the data lake host will take care of all those transformations, validations, and preparations formats. And simply all the teams can you consume this data seamlessly. That's where they are projecting. So let's see how it goes and how a mature data lakehouse looks into picture. Probably in an year, I'm sure of that. And I just have curated some of the blog posts and some videos that explains very clearly about what a data lakehouse is and what the difference between data warehouse and data lake. I just curated all those links into this. And so this is just another additional point. So as a data architect, we should be deciding that the copying of data gets lesser across different teams. So as you could see from the raw data, from the source place, the data gets stored into data lake. From the data lake, it gets stored into data lakehouse. And again, different teams are creating in different formats. Some will be creating as cube, and BA team will be creating as a they'll be extracting into the respective BA tool, right? In Power BI, if you import the data, then the data resides into Power BI. And when you schedule once in a day or once in a week, Power BI will be extracting from the data warehouse and storing into data into Power BI. And similarly, there will be some data exports as well. Like data scientists would be exporting the data in a CSV format to play with their Jupyter notebook, and all these things happen. So many levels of copying exists, and reducing the copying of data between different systems will help to have the latest data available across multiple different teams, those who are accessing the data. And we should define the architecture based on the customer's need, right? It's not that always ML can, machine learning is a silver bullet, or it's not that one particular data stack is a silver bullet. For example, let's take it as Apache Spark, right? So it's not the case. And even another thing is, if as a team, if I know Apache Spark better, I'll definitely not choose a Apache Spark for just that particular use case, right? The decision should be purely based on made purely based on the customer's need and the problem statement, and that's the experience we even got there, right? So this is just another slide because the sanitizer and the soap, this is what we are using pretty much. Most of us are using for the most number of times for the past 2 years. And I just placed this image over here. So if you link your application with the wrong database, or whether the application could be of analytics, could be solving for the analytics need or for the transaction OLTP purpose. If you connect it with the wrong database, then obviously even the database is of a capable thing, you will not get any outcome of that. So always choose the right database for your right need. And before I close, I take this stage to talk about the Azure Community Conference that is going to happen on November month. And you will be able to find complete details on this website. It will be of, it is going to be the India's largest Azure conference with 3 days with all type of tracks, database track, application development for the DevOps guys, for the CTOs and leadership kind of people. There will be multiple tracks over there, and global level speakers will be there. And totally we are planning for 10 live workshops and 100+ sessions. And obviously 30+ communities from India are working together to make this conference alive. And I take this time to quickly show you the website as well. Just give me a minute. So it's just acconf.dev. And as you could see, the website would be having very detailed information. You could dive in and check out, and even the speakers information are getting added, and we'll be adding more speakers soon. So just take a look into that. So with that, I have completed my talk, and if you have any questions, please let me know.
Yes, there are a few questions. So from Nikunj, I guess, Dinesh.
Yeah, should I read it out, or is there in the chat?
Yeah, you can go ahead.
Yeah, so my first question would be like when to choose MongoDB versus Azure CosmoDB versus Elasticsearch for a schema-less kind of entity when we don't know that what number of fields will be there for a particular entity. So it is same in line with your last before ending image, like wrong database choose and we should not be heard. Yeah, that's the first question, Dinesh.
Okay. The 3 things you told about MongoDB, Azure Cosmos DB,
CosmoDB,
and the third one is Elasticsearch.
Elasticsearch, yeah.
Okay.
For a schema-less entity.
Yeah. So the common thing is schema-less entity.
Yep.
Than telling that which one to choose, because I don't know the exact use case or the background. I can tell when not to choose one. Okay?
Sure. That's also fine.
Let me just tell first for Elasticsearch. Elasticsearch is primarily created for the searching capability, right?
Yeah.
If you have a huge data set, let's consider that your product has a huge number of tickets getting submitted by customers, and you might need to create a system to search for ticket, or some tickets that might be addressed already. The support engineers might need an access to search for the previous tickets that has been solved, and all those purposes, right? That is the primary purpose of Elasticsearch. First. Second thing is, if you choose Elasticsearch as your database, then you would not be having the privilege of connecting with different BI tools. You'd be able to seamlessly connect with Kibana only. That is the only actual seamless BI tool. Someone can argue that, oh no, Elasticsearch is supported in so on all those things, but I mean the most usable thing kind of thing. So Kibana would be the only option to be connected with. You'll not be able to connect with other BI tools. So if you have such a kind of use case, then don't choose for Elasticsearch. And next, coming to Azure Cosmos DB, if the other data platforms and all those things are already in Azure, then it is best option to choose is Azure only, right? Even in our case, why we did not choose Azure Synapse Analytics is because we did not have our NoSQL background in Azure Cosmos DB, right? We were having with MongoDB. If in case we were having Azure Cosmos DB as our Oltp system, then it will be a lot of time would have been saved for us for the migration. Right now we have chosen Snowflake on top of Azure. we did a lot of ETL work to migrate from MongoDB and store it into Snowflake. So if you have all other data stack and all other application stack in Azure, then choosing Azure Cosmos DB is the right choice. And
Okay.
and when to choose MongoDB is there could be many options. As I told earlier, if you have a sharding feature and if you have a multi-level multiple levels of data, that is MongoDB can seamlessly handle even it is of 4 or 5 levels of data. 5 levels in the sense the parent, child, child of child, child of child, child of child, like that, multiple levels. Even it can handle multiple levels of data. One thing. And on top of MongoDB itself, you'll be able to play basic level of analytics without any trouble. And sharding is very beautiful with MongoDB. I'm not sure how mature sharding is compared to Cosmos DB, but it is good in MongoDB. So if the purpose is just for the Oltp, for the applications purpose, and if you're completely independent, then definitely MongoDB would be a right choice.
Okay. Hello.
Yeah. Okay.
Okay. Yeah. So I think it's clear. That's one question, and I think I was missed that part. But like, yeah, when you have multiple relations, again, like you said, parent, child, 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 child of child, child of child, and child, then MongoDB is better option.
Yeah. And one more thing, MongoDB is best at this. If you have child tables, let me quickly take this time to show you a demo of KissFlow as well. Just a minute. And then in that case, it will be easy to understand.
Sure.
Child table I mean here is document. Obviously, what
We don't see your
what
screen,
called
by
as
the way.
table is here. It is called as document, and within the document also you can have another document embedded into it.
Sorry to disturb you, but we don't see your screen in case if you are sharing something.
Oh, I'm sorry. Yeah, I just shared the screen. This is the KissFlow application, and let me quickly. This is a development suite, so just don't mind if there is some the naming convention, all those things. So this is a very basic applications which almost all the procurement teams will be having purchase request, and each company would be having the designing this purchase request in their own fashion, right? So this is the business users will be adding different data fields which is of different data types, and like this they can even add any field on their own, right? So that is one thing. Different data types and different number of columns in each document. Behind this application, MongoDB is there, and purchase request will be in a will be saved as one document. And within that, the different rows, each rows that has created will be stored as different rows. Okay. So within this purchase request, there might be scenarios like you need to have tables also. So in this purchase request, I need to add one or more catalog items, and you would be able to create as many child tables within one table itself. In such a scenario, also MongoDB is playing a pretty good.
Okay. Yeah. Thanks. I think second question is also probably on same like when we don't know schema of a table, any recommendation? I think that's also covered this by the same, especially in terms of data, like when we have a data in TVs and it's a multi-tenant kind of environment. So any preference over in that case, like MongoDB, same MongoDB, Azure, CosmoDB, or any other NoSQL?
Yes, of course. That's a very common answer. Again, if it is of terabytes of data, then based on other perceptions, you can even think of choosing Azure Cosmos or Mongo.
Okay. And you showed some kind of auto scaling functionality. I think in Databricks when there is a 2 worker node and 4 a worker node. So similarly, do you know if there is a similar functionality available in SQL Azure as well, like a minimum DTU core or V core and maximum V core, and based on usage it will be like autoscale?
You mean SQL Server database?
Yeah, normal plain vanilla SQL Server database.
Okay.
But in
I'm not
Azure, of course.
sure.
In
Not sure
Azure, of
about that.
course.
Sorry?
In Azure, like not in like a it's not a independent standalone installation, but in SQL Azure.
Fine. No, I haven't came across that, but I heard that people are solving it via scripts. They'll be tracking that number of requests ahead, and that script itself will scale that core to a reasonable number of size, and that's where the problem is getting solved. It's not directly available in the UI. That's 90%, I guess. Yeah.
Okay, thanks. I think those are the question from me at least. Thanks, Dinesh.
Thank you.
Do we have any more questions? I think we don't, so we can wrap up the session then. Thank you, Dinesh, for the session, and thank you all for joining us today. Please feel free to scan the QR code and do the event check-in. Also, please share your feedback about today's session. It will help us to choose our topics that better suit our audiences. Do visit our Microsoft Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Thank you. Thanks, everyone.